This is pre-algebra lessons 11.4 and 11.5. I'm going to fly through these a little bit here. Okay, writing a proportion. Here's the deal. If I have two similar triangles, okay, similar as in they look the same but they're different size. Similar means same shape, just different size, right? So, okay, here's the deal. Let's say I have this. Let's say, well, let's do this one here. What if I have this right here, and I tell you that it is similar to this, right? I'm going to tell you that they're similar, same proportions. And this one is 6, and this is 8, and this is 10. And here, this is going to be 3, 4, and x. Okay, and I want to know what x is. I don't care that you know the answer. We're going to show you how to do it so you can do ones that you won't know the answer. What you do is you have to grab two similar ones, two of them that you know, right? And you go 6 and 3, and you put them over, and this one is, you know it's over 10, and this one would be over x. Does that make sense? You're going to grab, now, listen, these two will be the same proportion as these two. Now we have an x, that's what we're trying to solve for. So anyway, here, what do we do at this point? What do I do to solve this?
Line down the equal sign and solve.
How do I solve it? What do I do? Cross multiply, right? 6 times x is 6x, 10 times 3 is 30. Divide by 6, divide by 6, x equals 5. You knew that was 5. That's why it's 5. Now, I'm going to take that same exact concept, okay, this time it's going to be, this is 90, and this is x, and this is 95, and this is 40 plus x. And so all of a sudden you're going, oh, wow, right, is this one as easy? Can you just quickly do it like this? No. So the point is you need to know how to do it, right? So what did we do before? What did we do before?
We put them into fractions.
Okay, so we have to grab, these two are going to be a proportion. So 95 over 40 plus x, yes, equals, what do I do with this? 90 over x. Now what did I do to solve this? Cross multiplied. So this first one will be 95x equals, now this is 90 times 40 plus x, so 90 times 40 plus x. What do I have to do? What's it? Distributive property. I can't do anything with it. I can't, 40 plus x, I can't do anything with that, right? Distributive property. That's 3,600 plus 90x. Right? So then 95x equals 3,600 plus 90x. What do I do now? You guys know how to do this? What do I do? I have variables on both sides.
Minus, oh yeah.
Right? I have variables on both sides. What do I do? Which one do I get rid of? I have variables on both sides.
90x.
Why do I get rid of 90?
Because it's lower than 95.
Minus 90x minus 90x. That gives me 5x equals 3,600. Now what? Divide by 5, divide by 5. What is 3,600 divided by 5? Is it? It's not?
No.
What's 3,600 divided by 5?
720.
720. So 720, if this was feet or whatever, it would be feet or miles or whatever, right? That means that x is, that's 720, that's 720. Does that make sense? That means the length of this side would be 760, and the length of this side would be 720. Does that make sense? Okay. That's what you do. That's what you do. What if I gave you this, and I'm not even going to do it for you, but what if I did this? What if I gave you that triangle like there, and then I did this? And I told you that this whole thing, right, was 20 inches, and this little guy here was 8 inches, and then I told you that, this whole thing up here was x, and this right here was, x minus 4, Suddenly now, what would you do? Do you agree these are two congruent, they are two similar triangles?
Yes.
Yeah, and so you have to set up the proportion. I'm not going to do the whole proportion, but let's do the small one. The small one would be 8 over x minus 4, right? And then the other one would be equal to 20 over x. Does that make sense? And then you cross multiply and you figure out the answer. Okay. The next lesson is special right triangles. There are two special types of right triangles, okay? One of them is this. One of them is the triangle that is exactly 90 degrees, which makes this a 45 and a 45. Why are those guaranteed to be 45 if this is an isosceles triangle and this is an isosceles right triangle, then this length and this length have to be the same, which means that these two have to be 45 because what's true about the internal angles of triangles? They add up to, their sum is 180 degrees. So anyway, the special triangle is called a 90, 45, 45, right? Or a 45, 45, 90 triangle. That's a special one, right? And here's the deal. Here's what we know. Look at the bottom of page 602. In a 45, 45, 90 triangle, the legs are congruent, right? I mean, if it's a 45, 45, 90, those are both 45s. That means that these legs are congruent. And the length of the hypotenuse is the length of the leg times the square root of 2. So if I know this in my 45, 45, 90, if I know this, and I know that these guys are 5 inches, does that make sense? Are you up here? Eyes up here? Up here, up here, up here. I'm showing you so you get the concept. Shouldn't be in the book when I'm talking. If these two, when is this true? Well, I'm about to show you something. When is this true?
When is a 45, 45, 90?
Oh, it's only when it's a 45, 45, 90 triangle. I hope you understand that. That I'm about to show you something that only works when it's a what?
45, 45, 90.
Oh, I see. When it's a 45, 45, 90. If it's anything else, then this doesn't work. But if it's an isosceles right triangle, that means it's a 45, 45, 90 triangle. Then what I'm about to show you is true for all of them. You take the length of one of the legs, right? And you multiply that by what? What did this say? What did it say down here?
Square root of 2.
Square root of 2. So then here's the length of the hypotenuse. You know what the length of the hypotenuse is? Is 5 times the square root of 2. Do you understand what I'm saying? What is the square root of 2? You should all have a calculator out. You guys are in pre-algebra. So what is 1.4 times 5? Right? Isn't that what the length of the hypotenuse is?
Yeah, 7.07.
So it's 7.1. If we round to the nearest tenth, it's 7.1. That means this length here is 7.1. How did you figure that out? How did you figure it out? It's the length of the leg
Times the square root of 2.
times the square root of 2. I don't care what the length is, right? Giant one, right? If I tell you that's there, and this is a 45 degrees in here, and this is 45 degrees in here, right? Then, and this is 15. Without even doing anything on your calculator, Jade, what is the length of the hypotenuse? 45. Listen. So this is why I need you to, no. Listen, if this is the right angle right here, right? That means this is the length of the leg, and that is the length of the other leg. What did we just say is the length of the hypotenuse? I'm confused. Hold on. Let me draw one much nicer and neater so that there can be no question. How many degrees is that angle? 90, right? And how many degrees is this angle? If this is an isosceles right triangle, how many degrees is that? 45. That's the angle, right? That's not the length. That's the angle, right? This is a 45 degree, right? And this is 45 degrees. You know this is 45 and 90 because they have to be, because the inside of when you add up the lengths of the inside of a triangle, the angles, then it's 180, right? Okay. If I tell you that this is 15 inches, right, then what's the length here, Jade? 15. This is 15, right? 15 inches. Jade, how do I figure out what this length is? We could use the Pythagorean theorem, right? We could, because it's a right triangle. We could use that, which is a squared plus b squared plus c squared. But we don't need to, because They've given us a formula for this special right triangle. What kind of a special right triangle is this called? What's this special triangle called? Nope. It is a right triangle, but what kind of a special triangle is this? Look at the bottom of page 402. What kind of a special triangle is this? Bottom of page 602.
45.
This is a 45, 45, 90, right? And in a 45, 45, 90, how do I know what the length of the hypotenuse is? How do I know?
Leg times square root.
Oh. So then, Jade, without even doing any math at all, what is the length of the hypotenuse? It's the leg times, so what is the leg? Jade, what are the legs? So then what is the length here?
15 times square root of 2.
My goodness gracious, it's 15 times the square root of 2. What is the 15 times the square root of 2? Square root of 2 is 1.14 whatever, right? We just do whatever, do that, do the square root of 2, and then multiply that by 15. What is it? It's 21.2.
Yeah, 21.
Boom, 21.2 inches. Do you all understand? Does that make sense? You take the length of the leg and you multiply it by the square root of 2, and that gives you the hypotenuse. Does that make sense? So if, let's just say I gave you this. This is just so you can, well, right. We'll just do it. Yeah, it doesn't matter. Okay. You guys do one more. Please get this right. Here we go. I'm going to call this a right triangle, and this is isosceles, and I'm only going to give you one other thing, and I'm going to give you that this is 10 feet, and I want to know what y is. That's it. That's all I'm giving you. You can figure it out. Okay, so what is the length of this side, by the way?
10.
That one's 10, right? You know that, right?
Mm-hmm.
Right. How do you figure out, Gigi, the length of y?
10 times square root.
Now, why is that? Why does that work here? Why is it 10 times the square root of 2? Because it's a 45, 45, 90. And what is the rule about a 45, 45, 90?
And the leg times the square root of 2.
Is the hypotenuse. The leg times the square root of 2 is the hypotenuse. Okay, so then that means that y equals 10 times the square root of 2. What is 10 times the square root of 2? 14.1. So that means that y is 14.1 feet. Now, if I asked you to tell me the perimeter of this, what do? You take 14.1 plus 10, which makes 24.1, and then you add 10, which makes 34.1. How many of you got 34.1 feet? No?
I just didn't put feet.
Where did you put it?
40 because I don't know how to do the square root on my calculator.
I need to show you how to do that. Let's do that right now. Good. Okay, so square symbol. So you see how that's a squared symbol, and the one that's below the white one is a square symbol. So that's when you have to push the word second.
Oh.
Okay. Square root of 100. What's the square root of 100?
10. Oh.
Does that make sense? So you have to push. You have to push second and then square root for root. That's not it. But second and then square root. And now you type in, any one. That's square root of 1.
9.
Okay. Then you guys know how to do that now. There's another type of special triangle. Okay, it's the last special type that we're going to deal with, and it's called a 30, 60, 90. This is a triangle that looks like this, and it's where there's a 90-degree angle, a 60-degree angle, and a 30-degree angle. Does that make sense? 30, 60, 90. Looked on page 604, and you tell me, what does it say? What is always true about a 30, 60, 90 triangle? What does it say, Jack?
That the hypotenuse is always 2 times the shortest leg, and that in order to find the longer leg, you have to multiply the short leg by the square root of 3.
Okay, so here's the deal. The length of the hypotenuse is 2 times the length of the shorter leg. So, if I gave you this, and I told you that this was 5. What do we know right off the bat? What's y?
10.
5 is, and y is 10. Why do you know that?
Because 2 times 5 is 10.
Right, because, so this is 10, because they just said that in a 30, 60, 90 triangle, the hypotenuse is twice the shortest leg. Whatever the shortest leg is, the hypotenuse is double that. Right? Okay. And then what is the longer leg? It says the length of the longer leg is the shorter leg times the square root of 3. Okay, so tell me what the length of the x is.
8.66, which is 8.7.
So it's, how would you figure it out? It's
5
times the square root of 3. So x is 5 times the square root of 3. What is 5 times the square root of 3?
8.66.
8.66, so 8.7, whatever. Does that make sense? That is true for what?
30, 60, 90.
What if it's humongous 30, 60, 90? What if it's like huge?
Same.
So what? It's a 30, 60, 90 triangle. Shorter leg, twice that's the hypotenuse. What if I gave you the hypotenuse? What if on this thing, what if I gave you this and told you this was 12 feet? Could you tell me everything else? Could you tell me what x is and what y is?
Yeah.
What would x be then? 6. It's half of the hypotenuse, right? So this is 6. If that's true, then what's y? How do I figure out what y is? How do I figure it out? 6 times the square root of 3. It's the shortest leg times the square root of 3. Oh. How difficult is this? They've given you the formula. See, for a while you guys are still stuck in your, guys, they're handing you a formula. All right? All right. Let me give you guys your homework. Okay. Let me see here. Is that all I want to give you? Okay, here we go. I'm going to add just a little bit. Here we go. Page 600 to 601, 1 through 2 all, and 13 through 15 all, and page 605, 1 through 4. 1 through 5, all, and it's 15 to 17 all. 15 through 17 all. You guys have 20 minutes to get this done. I don't see any reason why you wouldn't be able to.